Yeah, so I'm working on our own ground control app for doing the ground control points because usually a surveyor, if you go zoom in here, a surveyor usually does a small area here and then you set a few ground control points and that's it. But what if you have thousands of ground control points and hundreds of thousands of images? I'm already over 200,000 images and over 1,500 ground control points. The problem is they keep recurring and it doesn't work because they need to be unique. The algorithm won't understand if you have twice the same name for a file with of course then the same pixels, like you have 5,000 like this and 4,000 like that. And then you have also the ground control points which would recur in names, ground control 1, 2, 3, 4, 5, ground control point 1, 2, 3, 4, 5. Your app wouldn't know which ground control belongs to what image. So I needed to come up with a solution to handle hundreds of thousands or millions of images. I'm now at almost 200,000 and 2 terabytes of data. But I cut it short to keep it fast and responsive because the loading time, actually everything is fast and responsive, even if you load 200,000 images. But the loading time for loading all these images is pretty high. We're talking about 3 to 4 minutes to load 2 terabytes of data into my RAM of my computer. So to speed it up, I like to work in seconds. I just took a small area only, a single survey grid here. And then I have here which verifies files if they are wrong or not. I tricked this now because I want to see all the images. So I just faked it and said they're all wrong. They're not, of course, but when you write software yourself, you can just fake that data. And here I say, for example, they're all wrong, right? And this is now the next step, which I just now, this week completed, just now on Friday I completed that. If you see here on the lower part, the X and Y, those are basically your pixels, right? Now if you don't zoom in, this is simple. Yeah, don't mind the pointer. I made the pointer a bit creative. Let's keep it at that. It looks a bit stupid, right? But we have white axis, we have black axis, we have red and yellow. So I figured, well, oh, also green. But I figured, well, yellow is a bad color anyway. It's hard to see on greenish background. So let's stick it to white, black, and red. Then whatever the background is, I will always see something. But for example, if you see how this moves, right? How can you keep it consistent? For example, it's 3.9 and 5.2. So let's say it's 3.9 and 500 roughly, the ground control point here. Now if I zoom in and I go again over the ground control point, I still need to see the 3.9, right? So if I do it right, I stay within that boundary. So if I zoom all the way in, and now I select the center point of this X marker, that's now the center, and that's on really 3.973.522. And this took me really a long time. Oh my God. There is so much coding I've done. Wait, I can actually show that here. Where is the... No? Oh yeah, there it is. Yeah, so this is one file, and the thing was, actually the form you're looking at here is actually this form. So, oh, this I can delete now. I don't need that anymore. But I made this beautiful coding, how that works if you zoom in and out and you see the right data. And then I said here, okay, update those datas, etc. And that simply did not work because when I went here, there was no focus. And then I said, okay, manually, programmatically put the focus on that wherever the mouse is. but for some reason in the background stuff happens, which Windows does. So, and this is a child form of that form, this one here, and this is a child form of this form here. And the focus kept switching between the layers of forms, and I was like, oh my God, oh my God. But eventually I figured it out. It took me really a long time to figure this out. I never did something like this, nested stuff. Also, I'm a mechanical engineer. I'm not a programmer. I don't do software development, usually. But I figured it out. And the trick is, I'm going to tell you that, this is the PictureBox. I overwritten the standard PictureBox and rewrote the PictureBox from Microsoft slightly with additional functionality to allow zoom. But the next thing of zooming was, how do I get the right pixel where my icon, where my mouse pointer is on? How do I figure out the exact location there? Well, this is the calculation basically. This simply works. I'm not going into details, but this is the calculation for that. If you move your mouse, this one is triggered, and then I overrode that with my own, here with an own handler. And in my own handler, I call for the coordinates, so do the calculation if the mouse is moving, get the X and EY from the mouse. So the mouse reports when you move like this, when you move with your mouse over the screen, the mouse reports always the X and the Y value on the screen where it is. Then calculate based on where it is on the screen, related to where your form is, and then relative to that where your picture box is, and then relative to that where inside the picture box your mouse is. And if it's outside of the boundaries, then show this, right? So you see, if I go outside of the X, you get here, oh wait, I need to move it around. If I go outside of the X, you get here this one, which is what you see here. And otherwise report the X and then report the result of the calculation. But you report the result of the calculation, but this is in the actual form, the control form. But I don't want to, in this control form, because that control form is already nested in this form. And if you can see, this form is form image pop-up, that is PictureBox zoom. So this is a nested form, but I need the data here. So for that, I did a public event here, which I trigger, and then it's triggered here, then I invoke it, and that one reports then back to the parent form, which is in this form. And in this form here, I subscribe this one to the event which happens in the PictureBox control, which is basically also a form. But the event in this picture, in this control, is then reported to this event, or subscribe, I should say, subscribe to this event inside this form. And here I then say update that label with the text. Now where do you get the text? The text is reported through the subscription. And the subscription goes then back to this one, which is here the public event. And this public event is triggered every time when you move the mouse, and then it evokes. Either it's this if it's out of bounds, then no. But if you're inside, then you report X, semicolon, or colon instead, right? And then the value of X, which is the pixels, you report it to a string, and then you get this beautiful effect. So this nesting, inside nesting, oh my God, but I finally figured it out. It took me a while, but you know, we have coffee, so that's a good one. But it's Friday evening, it's 18:21, and yes, mission accomplished. But this is only step one, because step two is I need to put the markers there on a layer. So this was just to get the data. How do I get the right data? The next step is put ground control points in a layer. Wait, let me close this now. Let's close this as well. And then here, this survey data on tab 2, on tab page 2, I'm basically going to do the background, OpenStreetMap background, and then an overlay which holds the ground control points, and then a list of all the ground control points, and then the images. And then the images will be colorized. So they will be black per default as here, but there, if there is no ground control point at all, they will be shown red. If they are within a certain bounds of a ground control point. So for example, look where the mouse is, right? Hope you can see it, it's here over the P, the mouse. If within an area, let's say 30 meters of that, all the images, they should see the ground control point. So that ground control point in a radius of 30 meters, it should be tied on all these images, or at least as much as possible, to where that ground control point is being seen on the image, where it is tied to which pixel on what image. Now, if it is not tied at all, it will be red. If images are outside of any range of any ground control point, they will remain black. And I will make here then some slider where you can set this radius to 20 meters, 30 meters, 40 meters. In my experience, 30 meters is more than enough. And then if you have 5 ground control points, which is a basic minimum, it would turn slight green, like let's say this green here, that would be okay. If it's 1 to 4, it would turn, I would make it orange. I think I'm going to do that, because if less than 5, it still uses for auto-rectifying the data from the ground control points, but it's not so accurate. At least the programmers of these algorithms that do these auto-rectifications for orthographic imagery, photogrammetry, the software developers, I had a conversation with them, and they told me 5 is actually a minimum for good results. If it's less than 5, it's better than nothing, but you don't actually get really good results. And but still a lot better than Google, that's a God-given fact. We're still talking then about 20-30 centimeter accuracy, what it can achieve, even if you hit only one ground control point to one image. But the aim is more than 5, and then you can narrow it down below 10. And the more, the better. So if it's 10, I'm going to make it medium green, and if it's then more than 20, let's make it dark green. Something like that. Yeah, and then on this tab, here I will do all of that. So this is then the next step. So this is management and organizing. And this tab will then be ground control point management, something like that. So there will be a layer with the images, and then a layer with the ground control points, and in the background the OpenStreetMap. And then the functionality, this was actually an experiment here, to do it here. But this is actually supposed to happen then in that new tab. But at least I got this to work. And then you get a list with all the data which you can export and import. Yeah, it's still a lot of work, but I'm happy that I got this part done already.